Swayam Prabha. Digital India. Educated India.
So currently I'm working with Crompton, and this is a range of air coolers which I have recently designed and launched in the market last year. So I'm only showing those projects which are actually in market and available in public domain. So apart from this, this is my Instagram page. So I also pursue hobby of papercraft and origami, and the most of these recent projects are done with Mumbai Airport, where they have used to conduct every year they have a festival, Jai Hai Museum. So these are some of the animals which are created for the uh, Jai Hai Museum festival. If you see, these are actually the state animal of the our seven sisters, which are northeast states. So some of the glimpses of this papercraft. Then regarding innovation, like what is innovation actually? It's very fuzzy. Anyone want to answer? Like quick answer, we can have an interactive session.
A creative way to solve a problem.
Okay. Anyone want to add that?
Something which is new, not yet present in the market.
Absolutely, definitely.
Modification, advanced version of something that is already existing.
Okay. So what is that advanced version? What is existing? So,
like bulb to tube light, for example.
Mm-hmm.
Bulb to LED bulb. Bulb was an invention, and the next thing that goes beyond that, it makes it usable and very much like accessible. That makes it an innovation.
Okay. Thanks, Sagar. So I will put forward the definition which I pursue as innovation. So it's simplified version. So what you see is dots, right? And this is what our existing knowledge base is. But when we start connecting those, so innovation is all about connecting dots. It's a simple definition. Might be easy, not that easy to digest, but once you work on it, you will definitely know. So anyone want to have any opinion on this?
In fact, Sarang, the dots keep increasing, no? Sometimes.
Yeah, it's always. It's up to us.
Yeah. So, in fact, it's like we talk about sunflower model where multiple petals are there, and all the dots have to look towards the user. That type of thing. Very, very nice. Yeah.
So it's actually like when we do it beforehand, we are not even aware of the much of dots there. But when you do the work, after that, when you realize that yes, we have connected that bridge in between. So going ahead, so this project is, though it's more on the form, but let's understand what biomimicry is. So this is what bio is means nature, mimicry is imitating something, is that simple. And if you combine both things together, it's like when we learn from the lesson, we call it as a biomimicry. So it could be a technical approach, it could be a form-based approach. It doesn't matter, but in short, we are getting some insight from the nature, and we try to put that for our problem solving. That we can term as a biomimicry. So the biggest inspiration for us is a nature. So when we solve the human problems by mimicking the nature. So nature has done already find out so many optimum solutions for it. So this project is about a seagull ceiling fan. It's commercialized it's launched in 2014. And if you see, there is a form relation to it. But apart from that form, the form is not only for the aesthetics purpose, but it also has a very functional nature as well. So going ahead, how this project started, I'll just throw some light on it. So basically, like when earlier when we were doing fan projects, so this is the insight which we picked, that whenever we are watching a TV, so we need to increase the TV volume when we don't hear the next person. Or when I'm having a dialogue with someone, I can't hear what the next person is saying. So when I was having a phone talk, why that is happening? Like when the ceiling fan rotates at very high speed, it also generates some noise. So that is causing the discomfort. So this was the insight which was picked up. It looks very simplified here, but it takes a lot of time to arrive at this. So a lot of actual user research were there. And then when going ahead with this insight in mind, I was having a ferry ride. And then I encountered the seagull bird. I was photographing it. So that really took my attention, because that bird, when you see, they don't flap their wings often. There is a very interesting things about seagull. That it's the only bird which you spot inside the ocean, because they use the wind current and they don't flap their wings very often. That's why they can conserve their energy and they can glide hours and hours in the oceans. So I also had then after when came back on desk, I searched on the technical papers. I actually got hold of some actual wing profiles and then took it ahead. So this is how the project started. So it's actually kind of this start was not like a normal projects which starts with marketing brief, but this is kind of the hobby projects which we do. So once those projects at a certain level, at the proof of concept level, then we showcase them to the marketing. So then we discuss this about the seagull bird, and then doing a technical study about the wing profiles. Then a lot of iterations I did with the digital model, actual paper models, actual 3D printed models. So a lot of refinement has done. So every revision is upgraded version of the earlier one. And while doing a concept around this seagull's bird profile, then when we are making a commercial project, we need to bridge this gap. So, and we are the best person who can bridge this gap about the business need and the user need. So we are well versed about the user need, because what's happened in what faced by the user and what ideas when we get, but that has to be commercialized into a successful product. So we have to study the other hand also. I think in Chakravarthy sir might have covered in their innovation lecture about this, the business side of the design. So this is initial concept where it is started. And when that time, this was the current product portfolio of the Crompton. And how the product will stand in this portfolio, how the price segment should be for this product. If you see, there were some decorative fans which were having lesser performance. But if you see, this fan will offer premiumness as well as it will have better technical performance. So this segment was not there earlier. And noise as a comfort parameter was not considered, because only people they were worrying about is about having a high speed fan which will give higher delivery. So I need to struggle a lot here with the marketing team that or business team, that okay, having that certain amount of airflow on your skin is required, but that doesn't necessarily mean that you should have that high speed of RPM. So that's an interesting way. And there are also paradigms in the people's mind that because whenever you want to change something which is not a part of the existing scenario, so people feel it is easy or very difficult to digest. So that's why what we did. So we did the basic concept of this. These are concept renders, and we did actual prototype of the fan in 1:1 scale. And we have also done, if you see this kind of detailing, so the 1:1 scale will give them the exact idea how the fan will look like. And there was also a question that will this fan provide the sufficient air which is needed. So for that we have to make a 1:1 actual prototype mounted with motor, and we have rotated it, and that air filling is delivered to the business people, so they can take the better decisions. And that's where the power of prototyping lies. Like even whenever you're working with Chakku sir, he will also always insist on having prototypes, mock-up models, and he will not satisfy with one mock-up model. So when you are building more prototypes, that you helps, but when you are demonstrating a concept which are out of the box, prototype is the tool, a very powerful tool, which can provide you the product experience for the target audience and the business people as well. So what we did this actual prototype. We have made one a raw tool of this blade, and then we actually did simulation also. So this what you see is the simulations to understand what is the airflow, will it deliver the same amount of air, and this way we were successful in providing the amount of air but at very low speed. So the existing fan which runs at 400 plus rpm, this fan will run at only 280 rpm. So and this is having very considerable saving in decibels, that is the noise levels. So later on, so this is what the blade profile which we have developed. And if you see these this is the later on we have filed a patent on this also. So this blade has this profile which is continuously varying from hub to tip and from the leading edge to trailing edge. So it's a continuously varying profile. Patent is also granted on this blade profile. So form, if you consider here, it's a very functional because it's, and that's functionality of this form is helped us to get this patent. Then we have then further commercialized with the range of possible trends which are available, and we have mapped this fan in different themes. And this is a concept for the ceiling fan with actual proposed colors. So we took the same color scheme of the seagull, which is gray and white, which is merging in modern interiors. And so finally the experience of the comfort. So though this fan is giving a high air delivery, it is operating at very low speed. And that's the key for the silent operation for this fan. And later on that we also find out that this fan air has a texture. So when we are designing a product, we are only thinking about the product design, but actual when the user experience the product, he does not see only the product, but actual the experience, that is how the air thrown to the user, what is the air texture providing comfortness to the user, that also matters. So this is a side profile of this fan. So any question on this? I kept it very simple because there are a lot of details which I can't show. I can only show.
We want to, see all the details. It's very nicely captured, Sarang. But we will, open it to the students. In fact, Sarang, today we were discussing with the students of where we were taking not biomimicry, not even formal analogy. We were taking emotional analogy of the animals. Like, for example, the horse.
Okay.
It is the power of the horse. Even that we were doing today because they already did Form 1 course. But anyway,
Right.
students, please go ahead and Sarah, you can keep the fan on for us. You can keep the fan on. So yeah, the other view also. Yeah, this is a good view, so very nice. So students, please,
Sir,
Hi.
at the end you said the airflow has a texture. So can you please explain it?
Yeah, interesting. So, like, see, when we are designing some products, we sometimes we are more into the product, and we thought about what is the age of the product, what are the form factors, age, surfaces. I will design those only details, right? But actually, when you operate this product, the basic function of the fan is to throw air from top to bottom. But how that air is thrown, that also matters. Like if you see this profile and if you compare with the traditional ceiling fan, so they generally have this flat blade which runs constantly like this. So what happens, like if you see at hub, the rotational speed of the linear speed is less, but when you go to the tip, the linear speed is very large. So when you throw the air is also, if you see, is thrown most from this point of the area, middle of this blade. And this profile helps you to throw more air. And because there are three blades which are rotating in circular direction, it creates a texture of the air. So if you that you have to feel. So when you operate a ceiling fan, different types of blades of the ceiling fan, you will feel the texture of the air. Like if you increase number of blades, it will be more smoother or fine texture will be there.
yeah. That's why all the American fans where they have air conditions, they use they use that type of four blade. They're very light. They have very little noise. They're very low speed also.
So it's very dependent upon the application. Like in Indian climate, what happens, like we are having a tropical climate, and in summer when it shoots up to 35 degree onwards, 35, 40, that time we need higher air velocity. But as sir said, for cold climate countries, they need a constant air, but they don't need very high air velocity. So that way also, if you notice the fans which are operated at Europe and India, there they use fan more for this circulation inside the room. They already has the thermostat to control the temperatures. But here in India, most of the houses, they only have ceiling fan as a cooling device. They don't have thermostat, they don't have air conditioner or air coolers. So their expectation from the fan is at the larger extent.
Okay.
Sir, I have another question. Hello.
Explain.
Okay, at the tips, I mean, majority of the noise might be created at the tips, right? Because like the same effect is seen in airplanes. The tips of the airplane's wings create the most air vortices. That's where the noise and drag comes in. So even could the same result be achieved with like a normal fan blade, but with like raised tips, like you see in aircrafts? Same silent operation.
Those called the winglets actually.
Yes.
So the winglet, this is like when you see this called a leading edge.
Yes, sir.
And this is a trailing edge. So whenever the trailing edge and leading edge meets, so it actually separates the air in two streams, top stream and bottom streams. So at end, what happens? There is a vertex formation happens at the tip. So if you see, this blade has a backward curved blade with a smaller tip. So the vertex formation is very less. In normal ceiling fan, it is very high. And as you rightly pointed, so as you rightly pointed that when airplane winglets, they have the vertical section, which actually reduces that turbulence at the tip.
So could something similar be achieved, or this could be further made more efficient if we had like winglets on the tips of this? I mean, manufacturing would be a pain, but yeah. If
Yeah, for
efficiency was
this fan, it's not necessary. So when we did the simulation, there we have found out that this is having a very less wind tip loss. We call it a tip loss. So that was not necessary for this design.
That's
Because
fine.
it's very similar to nature, right? So nature, it has efficient forms. If you try to mimic the natures, so even when bird flap their wings, their wing profile at the tip, it goes very narrow. So they don't have that much surface area at their tip.
Yes, sir.
And this is how they reduce their the turbulence occur at the tip. But when we do design an aircraft, that still at the tip, it's having a certain section there. That's why they need the winglet over there. But if you see the triangular wing profiles like Concorde or Blackbird, they don't have these vertical winglets there.
Yeah, especially fast aerial vehicles.
Yeah, that's the form. So it's very functional.
Oh, okay. Thank you, sir. That's my doubt.
It's a variable cross section, isn't it?
Yeah, it's variable cross section, correct.
Doesn't it make it heavy? Must be heavy.
Yeah, it's heavy. But actually, the weight of blade and the profile of the blade, these are two different parameters actually. So what contributes to your airflow is not your weight of the blade, but it's actually your profile of the blade.
Right.
Yeah. So there are also restrictions like considering the motor wattage, you have to maintain at certain levels of the wattage. So that exercise we done. We have done a lot of iterations and optimizations over it.
So this is not metal, right? It must be.
It's molded. It's a molded plastic.
In fact,
Injection molded.
Yeah, in fact, I was talking to other competitors of Sarang's product, and they were saying that Sarang was very, very early in the field, and they were the first ones to introduce plastic, and they were all still thinking, and now a lot of plastic blades are there. But when Sarang made this innovation, it's very interesting. He was very early in the market, and it made everybody look up and stand up on possibilities, and so it was like one of the very early designs. Sarang, tell us a little bit more about the form refinements. How why did you think about again this issue of training of perception and tiredness of perception? See, people are used to seeing a fan in a particular way, and you talked about the texture of wind. People are used to get that hard wind. They're very large number of people want that hard hit of the wind. Fan डाला तो हू करके आवाज आएगा तो खुश हो जाता हूँ. ठीक है, that type of thing. So that's a big challenge. I know you have been facing also with your marketing team and all. So how do we circumvent that? What type of education should we do? What are your experiences in that area?
So actually, touch upon a very interesting point. What we call here is a touch points. So what are the touch points? Is that the fan, it does its function, right? So it also need to connect psychologically with the people. So as you rightly said, the noise made by the fan, it is some people they associate with the directly proportional with the air delivery. The more the noise, the more the air delivery. Though technically both fan will operate at the same speed, but people pursue the fan which will be more noisier is giving more air delivery. So because this fan was performing silently, we are missing on that insights. So actually we lost on that touch point because people were not expecting ceiling fan to perform function silently. So that was a very interesting learning which we got out of this project actually. And convincing during that time about a slow speed ceiling fan is also a challenge. Like people were expecting a high speed. Like even we were the company who actually established in the market that high speed ceiling fan. Even if you search on the Amazon or Flipkart, you will notice that the ceiling fan are still sold with their speed definitions.
Yeah.
So they don't talk about what is the prime function which it delivers, like air delivery. But most of people, they only talk about the speed, which is actually not relevant to the people. So it's also very interesting that how the company sees the product and how the user perceives the product differently. So that's also a bridge which we need to connect actually.
But Sarang, you made a lot of changes. Even the way you held the blade is very different from the market. You have so many different things in a fan, which is so generic a product in the country. The way you put the pipe on the top, the covering for for the mount is also very novel. So you extended out of the box a lot in this product, right?
Yeah,
And I can
absolutely.
imagine how much effort that would take for sure within the company. Like the challenge is pretty strong. In fact, Sarang, what was very exciting is to see all your testing on the wind tunnel. Those slides became a little smaller for the online audience because we're no longer using projectors. No, we're all watching on our computers or mobile. So we could. I myself would like to see that wind flow one. If you have a little larger slide on how you did the flow analysis and how the form and that work together, and your final refinement, how you refined the form to come to this stage. So those two things.
Yeah. So initially, what we did. So actually, before doing for injection molded plastic blades, we actually made a raw tooling and made a aluminum blade with this cut. So this was the actual raw tooling which we made. This is tool made for only prototyping, where we have done this blade. So then with this fan, we actually did the testing, which gives us the result and confidence both. And we also took our help from our simulation experts, where we have analyzed the flow of this fan. So this is how the testing we do in the air delivery testing. Similar setup we have done in the simulation, and lot of stress test analysis also done, because the point I think sir has touched upon is very interesting, that the normal blade, it has a shank in it, which has a double twist bend in it, but this design doesn't has this bend. It is designed such that it will have only single bend, so that the blades are at an angle. But because the blades itself has a curvature continuous profile, it doesn't need the other angle here. So this is how this is also simplified. And also during the structural analysis and airflow simulations, it came out that it is much stronger blade and also very effective blade.
But I also like the point that when it is molded, because of the curve and all, it will become most
yes,
the molded blade. It's also designed for molding. That type of feeling is there. The flat blade will be very flexible. Blade like this would be really strong and nice, even if it's molded.
So when we earlier doing the user research, what we come out that when you buy a ceiling fan and first time when you clean it, that time you change the profile of your ceiling fan blade, because sometimes the blade is not accessible. So people they try to pull the blade, which actually destroys all the set angles in the blades. Then they starts rotating or vibrating.
Yeah.
And even this blade, I have this ceiling fan mounted in my house. I took it out and I wash it with clean. And because there is no change in the blade angle, the performance is still good.
Sarang, so it's fascinating to see how you were able to translate those inspirations from biomimicry. And I have a couple of questions. One is, the idea of noise, right? You mentioned about we will get performance of more than noise, the more the performance. So were you able to capture those? How many decibels? It is interesting to know. So is there any decibels that you were able to capture vis-a-vis current fan versus this one? How much of a reduction? And in terms of the technology also, we are seeing a lot of these new age brushless DC, BLDC motors coming in, and a lot of efficiency parameters and that have been talked about, right? In terms of bringing in more greener products and things like that. So probably if you could touch upon that aspect as well. And in terms of the thickness in general, like in terms of manufacturing, what is the performance in terms of the thickness of the blades? So were there any changes in terms of how you manage the thickness to kind of achieve better performance, and or probably with the materials that you have explored with this particular form? And in terms, I mean, this product is launched, is it? Is it available in the market? Or?
It was available in the market. It's a way back project.
Oh, okay.
You have to go back to 2014.
Oh, is it? Okay.
So it was quite ahead of the time project. Okay. And so the first point which you have mentioned about the noise level. So the normal ceiling fan which operates at 75 decibel, whereas this ceiling fan operates at 64 to 65 decibel. Okay. So you can consider 10 decibel is a quite a huge number.
Okay.
And that's why the people perceptions what we faced that time was about if it is not having that air cutting noise, it will not provide that much of air delivery. So that was the perceptions which we faced that time. I think your another question regarding the thickness of the blade. So if you see at the hub side and the leading edge, it is having higher thickness. That was about 2.5 something, and at the tip it goes narrowing. But that's because of this profile continuously varying. We got a very good flow simulation, mode flow analysis for this blade. So because the mode flow is also flowing smoothly across this blade, and we didn't face any structural problem for this blade. And the third question was regarding the noise parameter, right? Noise and
I think I was mentioning about the latest the BLDC.
Yeah, the BLDC.
How you're able to make it that efficiency count in this particular design.
So that time the BLDC was very nascent stage, not matured level, because those are having the sensor-based BLDC technology that time. So what we went that we have increased the number of holes for this design, which will give us the operation at the lesser speed.
And probably this is another question which is very nuanced.
Yes, please.
I mean, generally I am in charge of upkeep of the house, so I tend to clean the fans. So there is always the dust accumulated on the top, and we tend to see the dustless kind of a blades or things like that. Those new technologies are coming in. So were there any new things that are applied in this? Maybe does the form ensure that dust doesn't get accumulated, or which is like a flatter blades, you might have that issue, right?
So the dust accumulates because of the static which is generated there. So whatever your fan profile is there, it doesn't matter actually. But like the paint which you put on the top of your blade, when it interacts with the air at this cutting speed. So what happens, the static charge generated and the dust particle get attracted to it. And once they settle down, they attract more dust. So the dust layer forms. So I think in our recent product offering, the anti-dust fan blades are there, which are easy to clean and other stuff. But those technologies were that time were not available for this fan blade.
Okay. But it's fascinating to see how you use that biomimicry into this particular product form. It's very interesting. Thank you.
Yeah, thank you. So any other question, please?
Hello.
Hello, yes.
Could you also show some of your iterations or various alternatives before this finalized concept? Your thoughts on
So see, there are always limitations when you show so companies details on this platform. But these are some of these screenshots which you can help to make out. So what So though this is looks a simplified 3D 1:1 prototype, there are a lot of prototyping done beforehand to arrive at this stage. So what we did, we did the hand mockups. We also used wireframes to generate this profile, and then scan those profiles, get it in Rhino, then develop the surface, go back into the other software to refine the surface, come back into the Rhino. So a lot of iterations were done because the edge has to be seamless. When you work with the network point surfaces, you have to really be assured like the flow should be smooth. So a lot of digital iterations are done, prototype iterations are done. So paper prototyping, wireframing, 3D printing, all types of 3D printing, PDM, SLS, and then also actual aluminum blade tooled up samples, then actual molded samples of existing parts, which helps us to define the parameters which we should go for. What is the minimum thickness? What is the maximum thickness? So it needs a lot of iterations.
In fact, you didn't talk about inspiration, Sarang, how you were traveling to Elephanta. This time you didn't mention that story. you have our students. You have to mention all the stories. So like basically, the companies work on a efficiency and low risk, activity. So the whole ethos of a company runs on that level. So what happens when you come with something which is disruptive like this? This is like a disruptive fan. Nothing has happened to the fans for ages other than a little bit of technology now from to DC, BLDC, which is a great disruption on a technology level. But formal disruption, I call this a formal disruption in the fan segment, which never happened like the way it happened for my Z-line petrol pump. So that type of disruption, it's very, very difficult within an organized company to bring. So, so I'm like very, very proud of what Sarang has done. And, and that's why we want to, really see the journey. And that is fabulous. Any other questions, students?
Sir, I had a question. Recently, I had seen one video of that how owl makes the least noise when it flies. So it is because of its larger wingspan. So can you explain? Here it appears to be little thicker in the middle part. So how that can point be applied here? How does that work? I mean, because of there is for longer period of time there is air contacts. Is it because of that we are getting a lesser voice, or how is that working?
Okay, so first what you touched upon is the owl's wings, right?
Yeah.
So owl's wings, they are not very smooth. They have feathers which occupy all their wings, and they trap air inside it. So whenever they move, there is the airflow is not disturbed. So similarly, when eagle flies, it disturbs a lot of airs. So it's when eagle flies, it's more like say your jet which carries your bomber kind of aeroplane. So it needs more thrust. But when owl flies, it doesn't make any noise because the air flows smoothly without the layers when they're separated. When it goes from the top of the layer and bottom of the layer, those when they merge back at the end of the trailing edge, there is very less turbulent flow for owl, and that's why it makes very less noise. What is the noise basically? If you go back into the basics of the noise, it's a vibration. And why the vibrations are caused? Because of the like when you whistle, right? What does whistle do? It creates that air layers which vibrates with each others. That's the similar analogy when you took for the fan blade. When your wing profile moves in the air, it creates layers. And when the air layers, they interact with each other, they create a noise. So if you have a very sharp blade, like when you have say water current, try putting a blade inside it. If it doesn't disturb the water flow, it's very smooth, right? So that way, when blade moves in the air, if it not creating a vibration, but it is moving the air, then it is more efficient because some of your energy goes in creating that noise, which is not present here. So I think we are also consider this point, right, about these efficiency of the fan blade. The fan blade efficiency is keeping more prominent function as prominent, that moving air from one point to another, and reducing the other losses like noise, vibrations, whatever they are. Those are actually the energy losses. So when you do the explorations or you do multiple iterations, you will have learning from each iterations, which we refine into the next stage.
Thank you, sir.
Because there are some manufacturing limitations as well. Like when we do the metal blade, so it is cut, it is punched. So it has even at the leading edge, it has 2 edges. Even at trailing edges, it has 2 edges of that 1 mm apart. So actually it is when it's moving in the air, that point, which is a very small edge, it causes that noise.
Excellent, Savan. Thanks for again sharing this wonderful journey.